Hello and welcome. Today, we're diving into the complex world of cities, exploring what makes them tick and how we can navigate their challenges. Think about your city, the buildings, roads, people, energy, even the local weather. These aren't separate pieces. They're all part of an intricate network we call an urban system. Everything interacts: human activity, infrastructure, the natural environment. It's this web of connections that makes cities so dynamic, but also incredibly complex to manage. How do we make sense of this complexity? Traditional planning struggles with the sheer scale of interactions. That's where modeling comes in. Modeling is a powerful tool used in urban system science. Researchers create simplified, digital versions of cities. These computational models let us simulate how different parts of the city interact, how the city evolves over time, and how it might react to changes, like new policies or unexpected events. It's like having a virtual lab to test ideas and forecast potential futures without real-world consequences first. There isn't just one way to model a city. Different techniques capture different aspects. For example, agent-based modeling, or ABM, simulates individual actions. Think people choosing transport or households moving, to see how large-scale patterns emerge. Cellular automata models look at how land use changes over time based on local rules, like neighborhoods developing. System dynamics modeling helps us understand feedback loops, like how population growth affects resource use. Often, these methods are combined with big data, machine learning, and insights from social sciences to build a richer picture. One crucial use for these models is boosting urban resilience. How does a city cope with shocks like floods, heat waves, economic slumps, or even pandemics? Models allow planners to simulate these scenarios, identify weak spots in infrastructure or services, and test strategies to help the city bounce back. We can assess how strong our systems are, plan better emergency responses, and understand the social side of recovery. Modeling is also key for sustainability. Cities face huge environmental challenges. Models help us evaluate strategies to reduce our footprint, use resources more efficiently, and ensure fairness. We can use them to design smarter energy grids, optimize public transport to cut emissions, plan land use to protect green spaces, and understand the impacts of shifting to renewable energy. It's about making evidence-based decisions for long-term environmental and social health. The future of urban modeling lies in integration and collaboration. City problems don't fit neatly into one box, so researchers are combining insights from engineering, social science, environmental science, and data science. We're building models that include not just physical infrastructure, but also things like governance and social behavior. Importantly, this isn't just happening in labs. There's a move towards co-designing models with policymakers, community leaders, and citizens to ensure the research directly helps create better cities. By embracing modeling, we can better understand urban complexity and steer our cities toward more resilient and sustainable futures for everyone. That's a glimpse into how modeling helps us understand and shape our urban environments. Thanks for tuning in.